previous 5 millennia demonstrate human capacity to know. Driven by our passionate lust and zeal for satiating curiosity, we are a species driven to know. Not to speculate, but to know. Really know. We have developed some absolutely astounding insights in the last century or so. The people alive today, their parents and grandparents, have witnessed incredible progress in civilization and society. Leveraging that awareness has allowed us to develop machines that hurl us at incredible velocities. Some take us to our nearest neighbor in space, the Earth's moon, and to harness energies never before fathomed. By any standard or measure, our understanding, our model of how we thought reality worked at intrinsic levels, was the most successful model ever devised. Yet for all of those successes, there remained an elusive quest to bring everything together into a single cogent description. One short paragraph that intrinsically connected absolutely all that is. People have sought that solution with earnest, but there always seemed to be some catch, some elusive piece of the puzzle that eluded us all. Part of the real question is not about our successes, but why what we succeeded at does not go all the way to resolving all of the remaining issues. Why is what we have not working as completely as is required? Before the dawn of the information age, about 1905, a young patent clerk here in this office in Bern, Switzerland, published the first of 2 papers that were destined to rewrite science as it was then known and establish a new path for history. Little did he know then, and few since, the implications his logically correct model would have. The journey you're about to take to some may seem long, but it is but a single step towards the awakening to come. For the next few minutes, we are going on a quest for a new way to witness, indeed to experience existence. The realm in which we exist is more wondrous than anyone ever imagined, and the path forward is clear, and it gets more clear with every passing minute. This journey did not begin today, here with this video. It began back in 2004 on an unlikely journey that would ultimately revolutionize what it was we all thought we knew. That journey unleashed what would be a new philosophy of knowledge, a new way to interpret existence, and that would not just unify physics, but would couple all reference frames. It is fundamentally and literally changing the way we work and think. Right now, the most successful model of reality does not unify physics, nor does it fully couple all reference frames. The geometry it promulgates as a part of its definition cannot exist from a single geometric basis point as is required of all valid geometries. Yet we take these failings in stride. Why? The answer to that question is simple. Our successes have justified that approach. And as the old proverb states, the ends do not justify the means. Albert Einstein, in his own words, stated, "We cannot solve problems using the same thinking that we used when we created them." Einstein was more right than he knew. Every age of pioneering has its early adopters. Those willing to risk everything for a chance to see new realms and adventures. They carried with them everything that they thought that they needed on wagons like this one. They discovered along the journey, more often than not, that they simply needed more than they had brought with them, but they made do. They kept on, and they did keep on because they saw something of value in their journey. Those pioneering people were people of vision, determination, persistence, and perseverance. And they built a nation founded on liberty and freedom. But what that freedom brought to the world emancipated more than a people. It heralded in entrepreneurial thinking that goes with that environment. Leadership forged in that crucible is different than any other. Leadership forged in a free market economy puts opportunity in the hands of the imaginative, and that, more than any other, is why the United States represents what it does. It is no great surprise then that much that spawned the information age was fired in that crucible, and for good reason. This replica of Charles Babbage's mechanical machine was one of the very first computing devices ever created by mankind. Others, like the Antikythera mechanism, solved specific problems. They weren't generalized devices solving many problems like this device. Establishing a foothold in those early years and driven to exploitation through a world war, generalized devices helped a world at war to defend values of freedom and liberty in the pursuit of happiness. The evolution of these machines into full-fledged systems brought the information age into its early childhood. They were at first ungainly devices. Today, we take for granted the capabilities of these devices and indeed wear them integrated into our fashion. But it is not the hardware nor even the platform enabling the application programs empowering the citizenry which brings us here today, not specifically anyway. No, it is the concepts necessary to create and nurture this environment that brings us to this very inevitable point in our history. We could talk about concepts like object-oriented programming and abstractions, constructs, paradigms, and paradigm shifts, which at some point requires too a deeper and inevitable discourse. This environment requires a very specific approach to sift through the chaos and bring order to computing in the information age. Global enterprise seeks to nurture such work environments that thrive in penetrating such chaos and deliver cogent computing solutions that solve real business challenges. Such approaches to work take each element, put it into context, and deliver business leadership in their respective industry. Large computers are called systems for a reason. Their configurations are comprised of clusters of these kinds of elements that must work together in a systemic manner. Interdependent teams across the business, their vendors, value chains, and stakeholders each have a need to understand, but from different points of view. Each of these various precipices leverage the language concept of abstractions. Abstractions are a way of conceiving or of conveying a general idea without having to articulate or even know about lower order details. Unless you're a mechanic, your car may also be a good example. Many people just get in theirs and drive it without understanding the details of valve timing or electrical system operation. Their use of abstractions insulates and isolates them from those details because they do not need to know those in order to use the machine for their intended purpose. All abstractions work in essentially the same manner, even those we use in the sciences, even those we use and employ in the physical sciences like physics and chemistry. All abstractions insulate higher level concepts from lower level detail and minutia. They allow us great flexibility and power, but they carry too a caution. We should not ever forget that we are employing them. Over the maturing decades of the last century, the information technology industry took all of these various issues and slowly developed the concepts of systems engineering as a profession, practice, and process with unique tools, techniques, and methodologies. In 1990, these ideas were embodied into a professional organization, and today it is called the International Committee on Systems Engineering, or INCOSE. What is interesting about abstractions relative to their lower ordered details is their isolation and insulation characteristics allow for logical representation of those details. That is to say that there may be more than one way to describe those same details. For every logical view, there must be an accompanying physical view which supports it, even if there's more than one logical view of the same physical system. That physical system must be able to support each of those logical views. Something can be logically correct and still be physically different. I'm going to say that again. Something can be logically correct and still be physically different. So pause and reflect for just a minute and consider in your own life the number of examples where you can imagine cases where something is logically correct but physically different. This could be anything from the description of a state of a room's organization at your home or office, a dishwasher, or maybe packing a car for a trip. Working with a real estate agent, they may show you a building layout, but the actual building may be slightly different when you arrive on site. Stakeholders in the systems engineering profession do these kinds of things all day, every day, albeit with more complex systems. One must consider these issues configuring advanced computing platforms and systems if they are ever to meet the objectives established by any enterprise anywhere on Earth. Important here, though, is the use of abstractions to represent concepts and insulate us from lower order detail. We all use abstractions in this way every day. How many times do you get in your car without thinking about the mechanics of the engine powering it? The essential idea here is the same. Anytime in science when details emerge which cause us to consider old evidence in new ways, it forces what in global enterprise and in science is called a systems review. It is an analytical reconsideration of everything it is we thought we knew in light of the new insights. We then fold those results of that review into a net new foundation, and then we move on from there. So what and how do we take these historical threads and weave them into a cogent fabric? Well, they don't just form a fabric. They weave a tapestry of imaginable insight, incredible insight. Think back to your reflection of a logically correct view of a physically different system. Now, hold on to your seat, because what I'm going to make a statement, and that statement is undeniably true, but given the implications we've just discussed, hold immense and profound implications. Implications that are going to take you on a journey deep through the elegance of reason. Let's take the modern interpretive model of the universe. Let's write it down, all of it. The good, the bad, the ugly. From the smallest to the largest, every single equation, description, and rule. Let's take that and let's call it M1. Then let's focus on just the core elements, or the constructs of M1. That is, the constructs on which it is based. Many, if not most of those, were part of Einstein's original thinking. Remember, though, these constituent constructs employed by M1 are abstracts and are of a model of how we interpret reality. They are not the actual constituent of reality. This is a very salient point, and it is where many people get confused. They confuse the abstraction for the real thing. Now, what I'm about to say is at first going to seem very mundane and patently obvious. Remember, it is not the statement itself, but the implications of it in context herein. Ready? What Albert Einstein created in 1905 and again in 1916 were facets of a logically correct model. Reflect not just on this obviously true statement, but the deeper implications of it in the context of our broader thinking here. As you ponder that obviously true statement, think about the implications of that statement in the context of systems engineering and critical thinking. Think about the abstractions we use to describe core constituents of that M1 model. Think about how humanity has not just created abstracts of those constituents, but how we constantly use them. Our familial use of those terms has made us complacent in our critical thinking. Remember, abstracts insulate and isolate higher ordered ideas from lower ordered detail. What if that lower ordered detail were physically different but supported the logical interpretation? What if reality was in actuality different than how we have been interpreting it, but it supported the interpretation we have created? When we pause and ask these questions, we must ask why the current model, M1, does not unify physics. Then, as we review what it is we have written down, and we organize those lists, other ideas begin to form and new questions asked. Slow recognition starts to settle in, and some may repeat over and over again, what Einstein created was logically correct. Thinking about the implications of that statement in the context of a logical view of a potential reality having a physically different system underpinning our interpretive model of it, and given that M1 does not unify physics and reality is unified, we must ultimately conclude that this is the case. Stunning as it may be, what we have been trying to do since 1905 is pretend that a logical view is a physical system, and it is not. Being stunned gives way to being awestruck, and there must be another way, a more in-line way with reality, one that holds a potential to actually unify physics. Let me point out that many of the ensuing questions have been asked and answered in the books that we've released so far. What is stunningly amazing is that M5 does not discard anything we have done so far since 1905. It builds on top of it. It integrates it into the way we handle and use translation matrices. And so it is considered in the context of M1, but then translated out into M5. And so none of that information, that data, none of that work number one, it's not wrong. It's just in the context of the logical model that is M1. M5 does things a little differently, it considers things a little differently. But it builds on top of what we already have. It does not discard it. Some of you will continue to reject these notions as counterintuitive or maybe non sequitur. You may be thinking about those thousands and thousands of experiments and the data that they produce, which many consider to be empirical evidence. Well, part of the answer to that reaction is simply this. Logically correct experiments conducted in a logically correct fashion, immersed in a logically correct model, and is interpreting the universe in a logically correct fashion, will absolutely produce logically correct results, and that has absolutely nothing necessarily to do with the actual physical underpinnings of the universe. The only thing it proves is the logical correctness of what was performed. The operative word is necessarily. The point being that critical thinking and the scientific method requires us to ask, is there another way to describe what it was we just witnessed and rationalized? And the short answer to that question is yes. In fact, there is another way to consider not just all that data, but the results of the net new science, which has not yet embraced these concepts as well.